to be safe and clean drinking water to be provided to the hospitals through an ultrafiltration system and capacitive deionization modules if needed. And then this clean filtrated water is then heated by the Scheffler reflectors, which is standing outside the container, nearby the container, to produce steam for the hospital thermal requirements. This is very brief, and of course for the more technical part of the solution, my colleagues and partners are online for replying questions afterwards. And then apart from the containers, there is also a third sort of item for the infrastructure, which is this PV Med port. It provides a shelter area for around 8 people, also PV powered, and it is thought of as a 24-hour emergency power supply for off-grid and also for weak networks, and also for as a small offsite clinic or for certain vaccination campaigns or other campaigns that the hospital might have outside the main building. As the SOPHIA project, this is a summary of the activities we've planned. So in the first year since the project started, we've been mostly concentrated on the conception and design, prototyping and testing activities, defining the boundary conditions of the systems, and in accordance with the demo sites where the demonstrations will take place, and prototyping, designing and prototyping and testing the solar, the refrigeration and the water systems. Then as we go on now, starting on the second year, the manufacturing of the containers will start, and these will be installed and demonstrated at 4 sites across Africa. And then, of course, we have transversal work packages such as the business models, dissemination, communication, and project management. The geographical focus of the project, so our partners, the consortium is formed of 13 partners across Europe and Africa, 3 European countries and 4 African countries. And the demo sites of the project, the containers, will be demonstrated at 4 remote hospitals in Burkina Faso, Uganda, Cameroon, and Malawi. The first site in Burkina Faso is also a project partner in the consortium operating in Africa, and the other 3 have been already selected for a second phase of testing. Here we'll just, as I think it's relevant for all the projects here, as all the Green Deal projects, the SOPHIA has strong capacity building component to it. So we will be organizing demonstration site launch days and seminars at the 4 local demo sites, as well as training sessions to raise interest on the functioning of the SOPHIA systems and also for the technical aspects of it. The project will elaborate a handbook for building the systems on site, and also local workshops, trainings, meetings, or finding synergies with local companies. And of course, also regarding the market uptake strategy, so the project plans socioeconomic acceptance studies, as well as the life cycle assessment and life cycle costing. We will concentrate on identifying and defining the business models and the tailored value chain for the SOPHIA systems, and how this can be to ensure the uptake of it after the end of the project, and upscaling a roadmap for the exploitation of and the use of SOPHIA technologies as part of the green energy transition in Africa. So this is, of course, all activities that will involve a lot of different stakeholders, and how something maybe for future collaboration. Within LEAP-RE multi-annual roadmaps, we'll try to identify where we think SOPHIA is most fitting in the smart standalone systems, So SOPHIA systems will be plug-in, modular, and standalone containers that can be integrated to existing infrastructure at the remote hospitals or for health and social campaigns. And of course, something that can be expanded as the technologies are tested and validated. And also the process and appliances for productive uses, specifically for the refrigeration systems powered by solar technologies in the SOPHIA refrigeration container. We've summarized the interest for collaboration and clustering of the SOPHIA partners in 3 main areas. So capacity building, as mentioned, especially so local solar refrigeration and water stakeholders, as well as, of course, students, universities will be very interesting for the project, particularly in the demo countries. So Burkina Faso, Cameroon, Malawi, and Uganda, but also other partner countries. For example, in Africa, we also have partners in South Africa, even if it is not a demonstration site. And particularly, we have a demo site in Malawi, but not a project partner in the consortium in Malawi. So local contacts there can be of particular interest. And we can envision making potential joint trainings or other initiatives, and discussing with the local contacts, and then participating in our activities. Regarding the market uptake, so also local suppliers, installers, and manufacturers of solar refrigeration and water technologies in the demo countries, but across Africa, and activities such as workshops, identification of the stakeholder needs, so discussing best practices would be something very interesting for the project. And of course, anything from other projects and initiatives would be very valuable, and joint dissemination and networking activities with other EU-funded projects, other local projects at local, national, international level in Africa, Europe, and worldwide. And just discussions, clustering sessions such as this one, or joint communication would be interesting. And to close, I just show here the SOPHIA consortium. So the project is coordinated by the Hochschule Karlsruhe, the University of Applied Sciences in Karlsruhe in Germany. And the project consortium is in total 13 partners from 3 European countries and 4 African countries. And just as a summary of our social networks, so the website has a lot more information on our activities and the technologies. And in all of these social media and social networks, you can find us easily with the SOPHIA for Africa handle. And yeah, thank you very much for your attention, and we're looking forward to discussing with you further.
Thank you very much, Irene. Very nice presentation. And thank you for insisting on the potential collaborations that you see with LEAP-RE. I think it is precisely what we were expecting today. Just to let you know that here in Pretoria, there is approximately 40 people in the room now. So I think it's also great that they had the chance to listen at you. Of course, we will share all the presentations to the LEAP-RE community, and reciprocally, we will send you all the Pillar 2 and Pillar 2 presentations made so far. So due to the technical issues, I will ask to all the speakers to display their own slides, because it's a bit complex from here, but I'm not sure there is any problem about that. So Irene, thanks again. And I now would like to invite the representative of SteamBioAfrica project to take the floor, please.
Can everybody hear me?
I can hear you, yes.
Yes.
Okay, thank you. Good afternoon. My name is Dave Lillo. I'm very pleased to be sharing with you this afternoon the information around SteamBioAfrica. I have Hugh Parry, who is also part of the consortium with me this afternoon to answer questions if we need to. SteamBioAfrica is a consortium of about 17 partners working in primarily three countries in Namibia, South Africa, and Botswana. We are working in a number of areas, and I'll go through these this afternoon in the presentation. So a number of issues are in Namibia at this point in time. There's energy insecurity, there's water shortage, there's bush encroachment. And obviously, this project is trying to take some of those current statuses and moving us across to create some impacts that will create a better environment for the people in Namibia. The project works around a problem statement around bush encroachment. Bush encroachment is a degradation of savanna where the grasslands and grazing areas have been degraded due to overgrazing and trees and pioneer plants then taking over the area so that the area is degraded. And the farmers are required to clean this excess bush mass to be able to restore their farms, to be able to raise cattle and to raise sheep and to raise goats. Often this material is just heaped and burnt. And so this project really looks at ways of creating value streams for those products that are cleared as part of a bush clearing process. In Namibia, there's already a rather large industry already making charcoal and wood chips as part of their value addition to the bush clearing. And we are now looking at a third product, which is torrefied wood chips, so that they can then create more value streams for this product that's coming off the land. Torrefaction is obviously a roasting of the wood to remove the moisture and to increase the energy. And there are particular features in these products, which I will go through, that make them better than charcoal and wood chips. The geographical focus in Namibia is highlighted in the map that you can see. There are a number of tree species in that particular area, areas that are dominating and causing problems for the farmers. And we will be researching these particular areas in this program. We will also be researching areas in South Africa, as well as Botswana, with exactly the same issues. There might be different tree species, but they have exactly the same issues. So our primary focus is in Namibia, and our secondary focus is identified as South Africa and Botswana. The primary research area is around using biomass as a torrefied wood, as a combustion fuel, and it will be used as a commercial combustion fuel for coal in coal burning burners, as well as a clean, cheap, and sustainable fuel for domestic stoves and people who don't want to deal with the problems with wood burning and cooking with wood in those rural areas. So as I've discussed, the biomass will be used we will remove the biomass to restore unusable land. We'll reduce infield burning. We'll create extra income streams, and there'll be jobs that are created as a result of these value streams that are created. So there's both a climate effect to this, as well as an economic effect to this. This is a summary of our work packages in the project. So work packages 2 to 6 focus primarily around the technology. We've just completed our month 12 meeting, and the design and construction of the plant is currently being done in United Kingdom. maybe it is not in the slides anywhere, but this project is a continuation of a project that was done in Spain some years ago, and the information and technology and know-how is being transferred from that project, where maybe the need in Spain wasn't that high, to an area now in Africa where we have serious biomass issues that need to be dealt with. So those packages will go through the design and construction, installation, commissioning, the plant operation, all the way through to process optimization. That project will take the full 3 years. We have, as I've discussed, we've just finished month 12. Due to COVID, there have been some delays in the project in terms of the manufacturing of it. It was due to be delivered just before the end of this year in November. I think we're currently looking at March 2023 for the plant, the demonstration plant, to be delivered. In this project, there is only one demonstration plant, but we will be bringing in material from a number of the countries and the different species and testing those in the different areas. Work packages 7 and 8 look at the logistics and land management and ecosystem services. So this looks largely at the upstream part of the project. Are we harvesting sustainably? Are we disturbing the soil in terms of our harvesting? What are the soil samples? What are the carbon levels in the soil samples? So there's quite a lot of information around the upstream activities and both the biological as well as the economic aspects to that. Work packages 9 and 10 look at the market and the value chain. So those are downstream activities. Those are looking at, we've done market research in terms of what domestic consumers are currently using for fuels, what their budgets are, what their preferences are, how the value chains work, and those have been done in all 3 countries. We then will be looking at value chain development to see how we actually engineer so that the value chains that are created from this product are equitable. We've done some specific focus in the domestic value chain around gender equality. We have found that there are, certainly in Botswana, in rural areas of South Africa, as well as Namibia, there are male dominant processes that we believe we could look at to help create gender equality. And gender equality is a very high part of our process and our research. And you can answer some more questions later in terms of we can provide services to other people once we've understood some of the cultural issues in Africa and how we believe we could address them. Work package 11 looks at the life cycle studies to try and understand where the plants should be located, what the logistics are, and how these value chains could be created most efficiently. And then work package 12 looks at the project impact outcomes. We will be hoping to build and develop these plants in Africa for deployment in Africa. The technology itself revolves around superheated steam torrefaction. It's a continuous process. The material goes in one end and comes out the other end. There are a number of stages in it. The superheated steam dries it. It takes up to about 230 degrees centigrade, which increases the calorific value of the material. And during this process, there is condensate that's removed. And during the project, we will be investigating the value of those condensates to see if there are value in the condensates that can be engineered into other products. We are not adding any other products into the process. There are no additional chemicals or materials that have been added to aid the torrefaction. So it's purely the biomass that's going in the one end and coming out the other end. Superheated steam has been around for a fairly long time. It's a proven technology. It has a very high heat transfer, so there's not a lot of heat loss. The plant uses quite a lot of heat recovery in the cooling down phases to do preheating, so it's highly efficient. and it is in an inert environment, and the product that comes out is fairly uniform. It doesn't have from the outside to the inside the process, because of the steam, has made a consistent and a uniform product. Compared to other raw biomass or white pellets, the advantages are that the process automatically dries the material. It has a very low moisture content. It is hydrophobic, which is a huge advantage. It can be stored at places of consumption during rainy seasons and not be affected. It doesn't have to be stored in closed encounters. It is very inert. The bugs won't eat it. It's completely sanitized. It's easy to grind, so we can deliver it to the boiler people at different sizes, and if they need to grind it to a particular size, it's very easy to grind at the site. The particular areas of Namibia and Southwestern Cape in South Africa are over 1,000 kilometers from the coal fields. There is a very high carbon footprint in transferring this material, the mined coal from the mining areas to the consumption areas. We believe that there's a large market both in Namibia and in the Western Cape to use locally biomass that has very low value, and to add value to it, and then to replace coal in a co-firing environment or in a completely torrefied wood environment for a number of industrial processes where they can reduce their carbon footprint significantly. The plant this is a very short picture of what the plant looks like. The components are containerized so that they can be shipped to site and assembled on site. So it is very much a Meccano process where the manufacturing of the plant is manufactured centrally and delivered to site, and then assembled in a fairly quick process. In terms of the outcomes, we believe that, as I've discussed, that we're going to have a highly commercially viable domestic market, but also the industrial market, and that we will be able to offer commercial processes at the Namibia and the Western Cape are large producers of agricultural products. Those agricultural products are dried, they're kept cool, they are cooked, they are stewed. There are a number of industrial cheeses are made, whiskeys are made, brandies are made, and so all of these food processes need heat, and we'll be able to provide a low carbon fuel to these processes and be able to reduce their carbon footprint. During the process, and part of the packages that you saw from the work packages, that there's a large emphasis on knowledge transfer. So the project is not only looking at the industrial process of making the material, but we're looking at the upstream and downstream activities to make sure that we can build value chains where there is knowledge around both the collection of material as well as the sale of the material, and not just the mechanical processes that are in it. There is budget for training of entrepreneurs to be able to organize themselves and to be able to be suppliers of material as well as sellers of material. And as I discussed with you, there's a high emphasis on gender equality in building these value chains, because traditionally a lot of the SME businesses were dominated by males. Lastly, we hope that the 500 kilogram hour pilot will, after 3 years, will be successful. We will be able to, with the knowledge that's been built, to upgrade that to a 10 ton per hour plant. And the plans are in place for us to then fabricate and build these plants in Southern Africa, to deploy them to bush areas. So the idea is the plants have been designed to be close to the raw material, the value will be added in the rural areas, and then this product will be either distributed to commercial coal customers or domestic fuel distributors. And as I've explained to you, as we get product through, we will be testing the fuel in domestic cooking environments and making sure or deciding how applicable this is to replacing wood with a clean fuel, because torrefied wood does not create any smoke when it is burnt and once it's created. So that's where we are. I hope that we found that very informative. Thank you very much.
Luc Richaud from Audity France.
Thank you, Leonard. I just have a question from the previous presentation from Irene regarding the SOPHIA project, because in ENERGICA, so this is a Pillar 2 project of LEAP-RE, we are working in Burkina Faso as well. So I wanted to know, Irene, if you already identified the place where you are going to deploy the container, and if yes, where is it? Thanks.
Hi, thank you for the question. I hope that you can hear me. Yes, so the 4 demo sites have been already chosen. The first one is one of the partners of the consortium in Burkina Faso, the Leo Hospital, and the other 3. Sorry, I just need to find the exact names, but the Bubuna Hospital in Uganda, at Lusam Hospital in Cameroon, and the Malawi site, the Mua Mission Hospital in Malawi.
Yes, and maybe to add, the location in Burkina Faso is in the region of Sicily. It's south of the city of Leo.
From the audience, here in the room or maybe online? No question? Okay, so I now invite REFFECT Africa project. So this is in-person presentation. Nirvana, please.
Thank you very much. Just gonna wait for the presentation to come up. So whilst that's happening, let me just introduce myself. My name is Nivana Strikisun. I'm from the eThekwini municipality, which is in Durban in South Africa. We are one of the partners on the project. So I'm presenting on behalf of our project coordinator, which is the University of Cayenne in Spain. So REFFECT Africa is essentially renewable energies for Africa, effective valorization of agri-food wastes. Next slide, please. This particular project was funded under the Horizon 2020 Green Deal project. It started in November 2021. It runs for 5 years, so we will be continuing until October 2026. As I indicated, the coordinator is the University of Cayenne in Spain. There's 29 partners on this project, a combination of partners from Europe and Africa. 11 of our partners are from African countries and 5 are from Europe. From the 29 partners, 14 are involved in R&D. There's 12 companies and SMEs and 3 public bodies, so an NGO, a district assembly, and ourselves as the municipality. Next slide, please. Okay, so this is just a representation of where we're from, and you can see on the map the countries that are represented. There's 16 different countries, as I indicated. I'm not going to go through the detail. You can read through that yourself. But from the 16 countries, we have our 29 partners. Thank you. Next slide. As I indicated, I'm from the eThekwini municipality. So One of the demonstrators that form part of this project is located within our municipality. We are the third largest city in South Africa. Our land coverage is approximately 2,834 kilometers squared. Our annual budgets are approximately 50 billion rand. And our municipality has in the region of 30,000 employees. We are a highly indigent municipality, so a lot of our population lives below the poverty line. And in terms of the project itself, we have a demonstrator in our city, as I indicated, but we're also the coordinators in Africa. So we are assisting with all of the coordination processes for the project. We're also responsible for networking in African countries amongst the target groups and monitoring of the project in relation to the SDGs and the overall impact. Next slide, please. There should be more to this. Okay, there we go. So the overall aim of REFFECT Africa is to demonstrate innovative, reliable, and adapted sustainable energy solutions for the valorization of biomass waste from agri-food industry based on gasification technology. Essentially, what we're looking at is use of agri-food waste in each of the 3 demonstrator locations, converting that via a process of gasification into 3 products, being electricity, heat, and then of course biochar, which we will co-compost with other organic matter to create biofertilizer.
Next slide,
Next
please.
slide, please.
The
location of the demonstrators, the first one is
on-grid application in an olive mill in Morocco. So I'm referring to the map on the right. The second is a rural off-grid application in Ghana. So that's at a school, and it also incorporates a small medical clinic. The third one is the urban application
at the Clearwood Market in the eThekwini municipality. That market sells bulk fruit and vegetable. So it's a 24/7 major operation. The overall concept looks at providing electricity, heat, and then fertilizer that has been based on the biochar for different uses. That has been adapted to different technical and socioeconomic needs in each of the areas that the demonstrator is located in. Next slide, please. Our overall methodology and steps forward. So we started in November last year, as I indicated. We are completed with our research phase. We're currently working on the design of the demonstrator. That is being customized based on the different locations. So the city that the demonstrator is in, the amount of waste that's available, the type of waste, etc. Once those demonstrators are designed, we will then proceed with the construction of the actual demonstrators. So we're right now between phase 1 and 2. And once the demonstrators are built and commissioned, we start with the actual demonstration phase. As part of that demonstration phase, we'll then use the food waste, etc., to produce the byproducts of the process. The results of that will then be assessed with regard to the environmental, economic, and their social performance. And it is hoped that those results will then help us to replicate these particular demonstrators in different parts of Africa. The countries that are involved in Africa are clustered. So the West cluster, the North cluster, and then the South cluster. And the way that it is intended to work is that each of those clusters has one demonstrator, and the countries surrounding that particular location where the demonstrator is will be allowed to go to the demonstrator locations, look at the demonstrator, look at how it was designed, the impact that it's made, etc. And that forms part of our training and dissemination phase so that we then replicate in other countries. Next slide. Yeah, that's it. So that's our contact details. We have a website. We're on all of the social media pages, and you can follow us to learn more.
Do you have any question for Nevana? Here and online, please, do you see any question in the chat? No question in the chat, no question in the room. Nevana, thanks a lot. Thanks for being here as well. It was great. Great presentation. So I now invite Magdalena from ICLEI to introduce SESA project. Magdalena, please.
Hi, good afternoon, everyone. I hope you can hear me well. Just let me start with the presentation. So my name is Magdalena Sikorowska. I represent ICLEI and I am the SESA project coordinator. SESA stands for the Smart Energy Solutions for Africa. I'm not sure I'm not able to move the presentation. Excuse me for a moment. Yes, hopefully now it works. Excuse me for that. So as I was just saying, the SESA stands for Smart Energy Solutions for Africa. And this project is a collaborative project between the European Union and 9 African countries that you can see here on the map. It's basically Kenya, Ghana, South Africa, Malawi, Morocco, Namibia, Tanzania, Rwanda, and Nigeria. And we are aiming to provide the energy access technologies and business models that are replicable and that are able to generate jobs and economic development in Africa. And it's, well, how we are aiming to do so through the several local living labs. We will do it in the co-development process from scalability, and we will replicate the energy access innovations that will be first tested, then validated, and later on replicated throughout Africa continent. Our main objectives, and in here today, main principles of actions. First is to inform, both to boost the accessibility of innovative and affordable energy solutions, renewable energy solutions in Africa. And we will do it through the so-called online toolbox and as well extensive capacity building program. Next, we aim to inspire. So we would like to facilitate exchange and partnerships between Europe and Africa on the sustainable energy innovation. And we will do it through the peer-to-peer exchange within Europe and across pilot sites. The peer-to-peer exchange will be among business, cities, and academia. We aim as well to initiate where local innovators, both from Africa and urban and rural communities, will lead to sustainable energy. And we will do through so-called co-creation process in the living labs and the policy roundtables. As well, we aim to implement, so we will co-develop, innovate, and replicate innovative energy solutions that will be tailor-made for the urban and rural context. And how we will do it through the seed funds that are assigned to the open calls, and we will have as well startup incubator program for local innovation. And lastly, we aim to impact. So we would like to foster long-term partnership and exchange or innovative sustainable energy solutions. And you, of course, would like to create, you would like to make sure that the project is taken into consideration as well, the decision-making process. We have a specific modular approach for this project. So we start with the demonstration action taking place in the Kenyan Living Lab. Then different type of technologies and especially sustainable and smart solutions will be tested in the validated countries in the 5 living labs that are currently being created, and they are in Ghana, South Africa, Malawi, and Morocco. And then the lessons learned from the validation countries will be as well in a way replicated in the replication countries, but replication countries are the ones that can come up as well with their own solutions and as well with their own type of technology to choose from. And normally are the ones that are more advanced and more mature in energy solutions. So that the one that we are looking at are Tanzania, Namibia, Rwanda, and Nigeria. And you can see on the map, the test site is in Kenya, the red, no, the yellow countries are the validation countries, and then the red ones are the replication sites. And the key technologies that we are focusing on is the centralized renewables, so solar PVs. We have as well second life electric vehicles batteries. Then waste to energy systems or biogas. As well climate proofing, resilience and adaptation, smart microgrids and rural internet access. As I have mentioned before, we will run the incubator program. It's a startup program that will support testing of local innovation. And such a program will include training, business development, mentoring, coaching, as well coaching concerning technology, access to finance, investment opportunities, market uptake, to a certain extent legislative matters. Such a training will be offered to selected startups. The program itself will support between 10 to 15 startups that will be selected among the countries that I have mentioned before. We have just launched the open validation call just last month, so we are expecting to have results end of December. And as of next year, we will launch as well a call for the replication sites. So far, what we have achieved, the project started running last year. So this year, it will be the first year of the project. So far, we have designed the capacity building plan. As well, we have identified user needs assessment and as well evaluation framework. We are in the first year of reporting on the toolbox. As well, we are in the first year out of 4 years, so the first initial stages of the incubator program and business models and plans. We have as well the first 5 demonstration implementation plans for the validation countries. And what will be interesting for us to get a closer clustering would be definitely in the context of the capacity building, more particularly in, of course, in the validation and replication countries. So in here, I would be interested to see if we can synergize in one or other way. For market update as well, now we are running the validation call for Ghana, South Africa, Malawi and Morocco. So of course we are looking for potential SMEs with the technologies I just mentioned. They are open and they're on our website. So we are looking for the right companies to support. And then in the later stage, we will be also looking for the good partners to work with from the replication countries. So that's it for the time being. And of course, you can find us on the social media. And you can see that the consortium is quite big. I haven't mentioned that we are 29 partners between universities, private sector, and UN agencies. Thank you very much.
Thanks a lot, Magdalena, for this presentation. So from my side, two questions. As we have some countries in common, I would like to know if some LEAP-RE beneficiaries could attend the peer exchanges and living lab process that you are driving in SESA project.
Yes, to answer your question, we indeed intend to open it to the external participants, so to say, so definitely for peer-to-peer. We will actually have just a general assembly next month, excuse me, in 20 days. And we have the first regional meeting that will take place in Kisumu in Kenya. So for other regional events, I think we can definitely liaise and we can discuss. So that if your question is if it's open, it's open.
Free community, so do not hesitate to share this information with us. And second question regarding the incubator program. So with the Pan-African University for Water, Energy and Science in Tlemcen in Algeria, and LGI, we are currently leading the development of an innovation accelerator on sustainable energy or on renewable energy within the framework of LEAP-RE. So I think this clustering process also aims at not overlapping. So I will get in touch with you because definitely I think you are already progressing well and maybe more efficiently than we are. So this is great to know that you are implementing such an activity. Now I would like to open any question to the audience. Do you have any question for Magdalena? Yeah, François.
Thank you, Leona. And thank you, Magdalena, for the presentation. It looks very interesting. I have a question. Let me present myself. I am co-coordinator of Pillar 1 LEAP-RE program, where we implement call for proposal funded by funding agencies. My question is not maybe related to my activity in LEAP-RE, but in the incubator you are working with, do you have cooperation or links with investors in order to scale up the solutions when you have experimented it in incubators? Some links with, for example, international development banks or other investors who could be interested to support the scaling up of the technologies.
So to answer you that question, we are just still in the initial stage. So we are actually identifying the ones that could, cooperate with us. As well, we have dedicated, because we are working with Siemens Foundation, so we have a special we have grants that will support both validation and replication countries, but nevertheless, when it comes to investors, this is still not that developed. So in here, true, this is part of the project to of course, we are looking for scalability and replicability, and we would like to have it sustainable. So we hope that those businesses will be able to operate once the project is finished.
Thank you.
Any other question, colleagues? Maybe online? No? Thank you very much, Magdalena, for your presentation. And I now invite the ENERGICA delegates. So I'm Boris or Nadia. Boris, I know it's bank holiday in Germany today. So if you are here, thank you. And do not hesitate to take the floor and present yourself ENERGICA project.
Yeah, hello and good day. The bank holiday was luckily yesterday, so today we are officially working again. Can you hear me like this? Can you hear me?
We mostly only hear you.
Yes, okay. So I will share the presentation, and I hope you can see the full screen of the presentation right now.
Yes, we can see it.
Okay, great. Thank you for the possibility to present ENERGICA at the Stakeholder Forum, LEAP-RE, and to provide some space for us to present our work and create linkages with other projects. I just heard that SteamBioAfrica actually deals with technologies that are linked to whiskey production and cheese production. And as a whiskey and cheese fan, I'm really sorry to say that we are not working in this field in ENERGICA, but still I think we have interesting activities. Since ENERGICA means the green transition and energy access collaboratively demonstrated in urban and rural Africa among African and European partners. And on this slide, you can already see the consortium that is made up of African and European partners almost in an equal share. We are 28 partners from both regions. The budget is 12 million euros, and we are a young project in the 11th month since we started in November last year, November 2021, and the project will run for 4 years until November 2025. ENERGICA takes place in 3 locations, as you can see on this map. It is in Madagascar, which is the green field that you can see. It is in Nairobi in Kenya, which is the red box that you can see here. And it is in Sierra Leone in the yellow box that you can see on this map. And the demonstration locations, they differ in the solution that is tested there, as well as in its structure and context. So in Nairobi, we have an urban demonstrator. In Sierra Leone, we have a semi-urban rural demonstrator. And in Madagascar, it is a rural demonstrator. The overall concept of ENERGICA is to develop tailored and replicable methodologies for the application of energy access technologies and renewable energies, and tailored in a way such that from the business side, from the social side, and from the technological side, it is in sustainable use or in extended use beyond the project cycle. So it is this bottom-up approach which is underlying in the ENERGICA project. To ensure this proper uptake of the innovative technical solutions and the sustainability in these 3 contexts, we are reliant on energy transition boards in each of the contexts. So 3 energy transition boards that bring together stakeholders in each of the contexts that get in touch on the different levels with the solutions, and that might have an interest and say, experience or skills to share in order to make this more grounded in the respective context. As already mentioned, in the rural context, we are in Madagascar, and as you can see in the green field, these are nanogrids in peri-urban and urban Sierra Leone. This is about water purification systems and biogas, and in the urban context of Kenya, it is about smart e-mobility and battery storage. I will say some more words on each of the demonstration sites and the demonstrators in a couple of minutes. To outline what we are specifically looking at in the project, we can see here the special objectives. There are 8 special objectives. The first 3 objectives are linked to the technical solution and the demonstrator. So special objective 1 is to demonstrate the integrated productive use systems in innovative nanogrids addressing the water energy food nexus. Special objective 2 is on water purification and biogas in a low-tech style, cost-effective in order to address the water energy food nexus. And the third one, the urban grid flexibility and decarbonization through smart battery management for e-mobility. And you can see again that these first 3 special objectives, they are directly linked to the context. So special objective 1 with the nanogrids is the rural demonstrator in Madagascar. Special objective 2 is in Sierra Leone and deals with the water purification and the biogas. And special objective 3, the urban grid flexibility and the fleet management or smart battery management for e-mobility, that is the urban demonstrator in Kenya. Overarching special objectives are special objectives 4 to 8. 4 is to create dedicated local community-based structures for the uptake of the renewable energy technologies. So there are tasks and work packages that look at the technological fit of the solution for the location, at the potential regulatory framework and business models, as well as on the social structures locally. Speaking of the energy transition boards from the slide before. Special objective 5 deals with the uptake of this specifically tailored solutions from the 3 contexts and draw out learnings in the sense of a generalization and replication in other contexts, and feeds into the replicability strategy and a manual for replication in other contexts and other locations. Special objective 6 is on capacity building and knowledge transfer. Special objectives, circular economy models and local value chains to ideally embed the solutions. And special objective 8, which is very balanced in our project with equal share of partners from both contexts, is on fostering the collaboration. As mentioned, now some words on each of the demonstrators. We start with the nanogrids in Madagascar, which is the rural demonstrator. The context is such that we have a 5% electrification rate in rural areas and 17% in an overall average. With a low population density of 43 people per square meter, which basically translates into a difficulty to extend the grid for sparsely populated areas, coupled with low income, especially in rural areas. So the solution with the nanogrids would involve solar-powered direct current nanogrids, powering 3 times roughly 100 to 200 households with a pay-as-you-go solution. This as an anchor load is tailored to rice hullers, cooling devices, and water pumping, which is locally used and addresses the water, energy, food questions in that region. The peri-urban demonstrator, the biogas water system in Sierra Leone, faces a context where only 28% of health facilities have access to reliable electricity in sub-Saharan Africa. Food security is directly linked to access to fertilizer, and long-term sustainability of agricultural production therefore relies on the replenishment of soil organic content to maintain the fertility. The solution in this context, as mentioned before, are small-scale biogas digesters to serve as a generation for electricity and heat to a local hospital, with a side product of roughly 3,000 kilograms per day as a residue of fertilizer to be used in the surroundings. In coupling with the water purification system by Arensis, we will also in this context tackle the topics and the modelings of the water, energy, food nexus issues on site. The urban demonstrator in Kenya deals with electric motorcycles and swappable battery charging. The context is such that Kenya has put itself on the forefront of the transition to a low carbon economy through the Climate Change Act of 2016 and an Energy Act of 2019. 85% of the energy is currently produced from renewable energies, including excess production of about 800 megawatts. Challenges remain in various fields, especially in the transport system, where we find like old vehicles and not ideal operation which brings hazardous particle emissions affecting the environment and the public health. Therefore, in this urban context, the mobility solution targets swappable batteries in combination with electric motorcycles as a fleet. 15 main motorcycle hubs in urban and suburban areas of Nairobi are therefore operated, monitored, and optimized. And the demonstrator thereby will focus on the behavior of the swapping, the location of the swapping stations, the payment system, and to sum up all of this, the telemetry optimization. From our perspective, looking at the tasks and the activities, we would be really interested in exchanges on methodological and technical approaches, for example, focused on energy services or productive uses of energy. Water, energy, food nexus, as you have seen, is the topic in two of the demonstrators. Hydrogen, I heard it before in the announcement of this session, is a topic as well. The other part, the socioeconomic challenges, speaking of the transition boards, involving the local stakeholders, the co-creation of energy solutions, and the generation of local energy communities bottom up, is a second area where we would be happy to connect and discuss further. And the replicability, basically being produced out of the bottom-up approach, taking these tailored insights back up again to a higher level and learn from them in order to generate a generalized view or a manual with points to keep in mind when the solution is scaled or replicated or transferred to other places. And that involves the technical way, the business and market approach, the regulatories, and the capacity building. So we would be very interested to discuss further about these topics. Thank you very much.
Thank you very much, Boris. Is there anyone here willing to ask any question to Boris regarding ENERGICA project? Is there any question online? Still no. So Boris, it was clear enough. Thank you very much. We look forward to meeting you again soon. I saw that we have also some partners in common, so I think it will be also more easier to identify commonalities. Nanoe and ODT are also part of LEAP-RE program. Thank you again for being here today.
Thank you very much.
And now I would like to welcome Luis from Universidad Politécnica de Madrid to present SOL-AQUA project, which is the last project to be presented this afternoon. So Luis, if you are with us, you can take the floor and start sharing your screen.
Thank you very much, Leonard. I'm going to share my screen. Can you see my screen?
Hear you, it's perfect, you can go on.
Thank you very much. My name is Luis Narvarte. I'm very happy to be here in this forum, and I would like to present the SOL-AQUA project, that is an European initiative for the installation of large power photovoltaic irrigation systems. The problem is clear. All of you already know that the electricity bill, especially for irrigation, is more and more expensive. And photovoltaic irrigation systems can be a solution for that, not only from the technical point of view, but also from the economical point of view. The SOL-AQUA technology is a new development that already has a TRL9. It consists of photovoltaic irrigation systems that can pump water without the need of the grid and without the need of batteries. So as a concept, we can connect directly the PV generator to the motor pumps used for the irrigation of the land through a set of frequency converters in order to pump at variable frequency. We can pump more water flow when we have more photovoltaic power, but when we have less available photovoltaic power, we can continue to pump, but at less frequency. This way, we don't need the electricity from the grid, just the photovoltaic energy. And as we don't need the batteries, we can pump water for irrigation with a cost saving of more than 50% when we compare with the cost of the electricity from the grid, and savings of more than 70% when we compare with pumping with diesel motors. We can also use other configurations based on this innovation. For example, we can supply electricity to the frequency converters and the motor pumps with the PV generator, but also with the grid. But we can choose in which periods we can use the grid. This way, we can use the grid just in the periods with the cheapest tariffs, but in the periods with more expensive tariffs, we can use just the PV power. Okay, so we can adapt the technology, this technology, to the requirements and the needs of the end users. But we are not working only with technology, but also with the financing models for this technology. I've just said that the photovoltaic electricity for irrigation is much cheaper than the other alternatives, but it has a great disadvantage. You have to upfront the whole investment in the photovoltaic irrigation systems at the beginning. So in order to avoid this barrier, we have developed and we are proposing an innovative financing model based on PPA contracts. A PPA contract, PPA is the acronym of Power Purchase Agreement, is a long-term agreement for the purchase and sale of clean photovoltaic energy for irrigation between a PV energy supplier that will be the owner of the PV plant, of the PV irrigation systems, typically an investor, and the consumer, the client. In this case, the irrigator, the irrigation community, the farmer, and at a fixed price during the whole duration of the contract. This financing model based on PPA contracts has a great number of advantages for the irrigators. The first one is that the irrigator has no need to do the initial investment. The farmer, the irrigator, only pays for the kilowatt hour that is consuming. And this kilowatt hour at a lower price than the current price that is paying for the diesel or for the connection to the grid. And fixed for 25 years, because this is the duration of the PPA contract. This way, the farmer saves from minute one, from the beginning of the operation of the systems. This is an advantage compared with other financing alternatives. As the price of the kilowatt hour includes the installation of the systems, the maintenance of the systems, and the financing cost, the farmer is not obliged to do the maintenance of the system. And also the PPA contract has a service guarantee. If there is any failure in the photovoltaic irrigation systems that cannot be solved in less than 48 hours, the owner of the PV irrigation system must provide to the farmer, to the irrigator, with an alternative power supply. And finally, in order to produce the most of the added value locally, the installer and the maintainer of the photovoltaic irrigation system is local. So, which areas of application this technology has? First of all, the agriculture, for crop irrigation and for medium and large-size farms. But we can also find other areas of application. For example, the drinking water supply for cities or for large, big villages, and also for other applications like aquaculture. What can SOL-AQUA contribute to this forum, to this big project that you have right now? We can offer the transfer of the technology. We can offer the training of researchers, installers, and farmers in order to do this kind of PV irrigation systems with the needed high quality for them to work for 20 years or more. We have also produced materials such as technical specifications, best practices in the installation, operation, and maintenance of this kind of systems. We can produce the financing model ready to be presented to national authorities or regional authorities. We have developed also the PPA contract model ready to be used in real projects and so on. And what is SOL-AQUA looking for presenting this in this forum? We are already doing the market introduction of these photovoltaic irrigation systems in Southern Europe, in the countries where irrigation for agriculture is needed in Europe. We are installing a set of 100 megawatts in terms of more than 2,000 different installations in Europe. Now we would like to do demonstrators in African countries of this technology together with this financing scheme. We are looking from demonstrators from 100 to 500 kilowatts in real operating conditions. We are looking for research centers, but also for installers interested in this kind of demonstrators. And we are looking for also for financing institutions interested in implementing this PPA contract based financing. For example, the African Development Bank, the World Bank, or national banks in African countries. And that's all from my side, Leonard. Thank you very much for the invitation and participating in this very interesting forum.
Impressive project. So I think with TRL9 and the model of the PPA, you are way further in the implementation of your project. Very ambitious. Is there anyone here wanted to react? Dr. Labed?
Hola Luis, ¿qué tal? Soy Labed Sifedin.
Oh, Labed, pleased to meet you again. Pleased to meet you again.
Oigas, no?
I can hear you. I can
me?
hear you. Yeah, I'm very happy to.
Thanks a lot. A pleasure to see you again. I would like to ask you one question. Is there any pilot project in Spain already with this PPA agreement? And how far we can translate this to the African context that you already know? Thank you.
Thank you, Labed. Can you hear me?
Yes.
Yes.
Very happy to see you again, Labed, my good friend. I would like, in order to answer to you, we are doing already photovoltaic irrigation systems for irrigator communities in Portugal, Spain, and Italy. For example, next week, I will go to do the quality control of a 1.5 megawatt irrigation systems in the north of Spain, in Huesca, close to the Pyrenees. But we our goal is to do as many projects to complete a total power in Southern Europe of 100 megawatts. With this financing scheme, with PPA contracts. We are working in Morocco to introduce not only the technology, but the financing model. And we have contacts with Senegal in order to introduce also both things. But I think this application is very interesting for other uses, not only for irrigation of farms. I know some projects in Nigeria about aquaculture that would be very interesting for that. Okay, I hope, I wish we can do this market uptake also in African countries.
Thank you very much. Lotfi?
Lotfi Bagdi from University of Lorraine, France. Thank you for your presentation. I'm more in electrical engineering and not in financial, but I think that the most difficult part of this project is mainly you have regulations that are different in each country. And as you are in Spain, you don't know them. So you must have your partners, local partners, lawyers in each country. So this could be a big challenge. Do you have contact with African Union involved lawyers or so on?
Not enough. This is the reason I'm here.
We don't hear you. You are muted.
Can you hear me?
Try again.
Can you hear
it's okay
me?
now. Go on.
I was saying that not enough. This is why I'm here, telling you this. But in any case, take into account that we can work, we can operate this photovoltaic irrigation system in an standalone mode. That's to say, without grid connection. This simplifies the permits and the potential impacts of...
No, I'm not talking about electrical. I'm talking about regulation in regards financial regulation.
Financial
not
regulation.
Regulation of grid operator or TSO.
Yes, this is the main novelty of this project, this kind of financing, but take into account most of the very large PV plants that currently are being installed in Europe, but also in Africa, works with this kind of financing schemes. So the only thing we are doing is to make possible that smaller farmers can take advantage from this kind of financing schemes. From the point of view of SOL-AQUA project, we must aggregate in order to make feasible this financing scheme. But from the point of view of the farmer, of the irrigator community, it is a possibility to take advantage from the financing schemes that very big projects are using.
Thank you very much. Dave, do you have any feedback regarding SteamBioAfrica about that? If you want to complement.
Sorry, just to repeat the question, what is in terms of aggregation?
Sorry, we did not get you. Can you please repeat your question?
I asked a question on the chat. Where are the pilot projects for SOL-AQUA in Southern Africa? Are there projects in Southern Africa? I know they're doing it in Morocco, but are there projects in Southern Africa for SOL-AQUA?
Thank you, Dave. We did a mission some years ago in 2018 to South Africa in order to let some universities and farmers to know this technology. But we after that, with the pandemic and so on, this link was stopped, was broken, and of course, I'm looking forward to connect again with these potential partners that we met that year.
So we are having in South Africa, I don't know, it's probably been reported elsewhere in the world, we are having a shortage because our network is constrained. So there are certain farmers at this point in time, plus there are people that are doing water purification and a number of pumping projects where the people are saying is that the load shedding and is causing problems with their production. So I think at this point in time, it would be very interesting to hear how this kind of solar pumping system would get around the problems with the grid instability at this point.
Thank you very much.
Thank you, Dave. Thank you, Luis. Do you want maybe to say a final word, Luis, or is it okay?
Thank you very much. Thank you very much to all of you for your words.
Thank you. Well, thanks to all the projects that took part today to this clustering workshop. Thank you also for you being here and online. And sorry again for the technical issues, but I think it was very interesting. So SophiA, SteamBioAfrica, REFFECT Africa, ENERGICA, SOL-AQUA, and SESA, you are now part of the LEAP-RE community. We were not enough, almost 100 projects. So actually, today we have been delivering a digital tool, an app. So we will encourage you, we will share the link with you in order you to create an account. So you will receive a code to get in touch with the LEAP-RE community. So just a remark, I know that some of you have some trouble to connect to the app because you must receive a code, but the code makes some time to arrive in your mailbox. Please check your spam. But basically, this is a first answer in order to build this AU-EU community of projects dealing with sustainable energy. So we are once again very pleased to welcome you in this community. in this platform, we will share all the presentations that have been made between yesterday and today on the Pillar 1 and Pillar 2, and the 6 presentations that you saw today. You will have also the possibility on this platform to create an individual profile as well as an organization profile, so that you can identify maybe potential partners, you can share events, you can share news, publications, even funding opportunities. So this is, as I said previously, a beta platform. It will evolve in the next months, and we are looking forward to receiving your feedback also in order to create more featured services and more adapted services for this community that we are going to create. So this is for the short-term parts. I think that for the mid-term part, we could investigate the possibility to participate in common events, because we are all participating in many events in Europe and Africa. We have a lot of partners in common, a lot of countries in which we are working all together. So sharing this news on the digital platform that I'm going to share maybe could be an opportunity to investigate the possibility, why not to create a big forum, a bigger forum than the LEAP-RE than we are having now, by involving the 6 projects that we are discovering today, but maybe others. And over the long-term perspective, you know that LEAP-RE is also working on the possibility to deliver an infrastructure in order to organize and sustain this community among the projects between Africa and Europe, working on sustainable energy. So we will keep you posted on the next step of these important activities. And once again, I would like to thank you all, especially the representative of the 6 projects. And I think that we can now close this meeting. Thank you all. Thank you.
Thank you. Goodbye.